Photons. Are they really just nature getting all a little bit hot and bothered, a wee bit sweaty? I I'm just saying that the CMB actually seems to project the temperature like about 2.37 Kelvin. We conjecture ahead.
Although this is going to be weird, and it's going to be about a different.
Title of the conference was something like "Ground Truth" or "Turtles All the Way Down," and so it seems as though there's one Ruliad. I don't think it rules them all, and it might be just hyper turtles all the way down.
Yes, it's on the back of an infinite number of hyperruleal turtles.
Various people are commenting on the outrage of hacking the universe on a MacBook Air.
Hey guys, what's going on? Photons. How do they even work? Let's take a look at some stuff and things on the internet. Links are in the doobly-doo. Alrighty. Over here, we have a photon brought to us by our friend Wikipedia. Yes, this is about the elementary particle or quantum of light for the use to see Oh, apparently it refers to more than one page. These things happen. A photon from ancient Greek. Photos, light, is an elementary particle that is a quantum of the electromagnetic field, including electromagnetic radiation such as light and radio waves, and the force carrier for the electromagnetic force. Photons are massless, so they always move at the speed of light in a vacuum, about 299 yada 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 meters per second. That's pretty freaking fast. Or like 186,000 miles per second. The photon belongs to a class of bosons. Those are essentially what the force carriers. It has the integer value because otherwise it's a baryon. It's gonna have some mass there, even though we won't get into that. As with other elementary particles, photons are best explained by quantum mechanics and exhibit wave-particle duality. What the heck is that? Wave-particle duality is the concept of quantum mechanics that every particle or quantum entity may be described as either a particle or a wave. It expresses the inability of the classical concepts, particle or wave, to fully understand the behavior of quantum scale objects, as Albert Einstein wrote. It seems as though we must use sometimes the one theory and sometimes the other. Well, at times we may use either. We are faced with a new kind of difficulty. We have two contradictory pictures of reality. Separately, neither of them fully explains the phenomena of light, but together they do. Now, I'm just saying that's really pretty neat. Why might that be the case? Is our reality the reality we think it is? Or maybe it'd be a wee bit different. Different folks just talked about that. It's on Gravity Podcast, and Jonathan Goodrod went through ADS CFT, like the 1x1 plus 1 dimension. 1, to be fair. Hey, everybody. Snacks and Math Pig. Only when Math Pig makes love. Oh. Well, you are a very bright guy. I need to hang out with you guys more often. But all I'm saying is, okay. Yes. Can you sweat out talks? Yes, I use this. It's from Britannica. What a diversity of sources here. Don't want to just say we're just doing one thing. But, okay. Our skin isn't actually an excretory organ. The skin is the outer layer, but it seems to come from the skin. So it's coming from the skin, but we get sweat there. Could there be something coming from our, let's say, boundaries, if you would? We're making assumptions. We're conjecturing here. We had like an ADS CFT model, boundary and stuff. We have to use some of these things for, I think, black hole mapping and stuff like that. It's very interesting. But I listened to a great video last night. I need to look more into. But I'm just saying that, okay, the come on drops, that's kind of cool. They maybe some drops. Are they all the same? I don't know. There happens to be salt in there and often, and at least it tastes that way. I'm not going to make the comment I was thinking at the moment. We'll save that for another time. Oh, yes. This is from astronomy.com magazine. That sounds like a reputable thing. Oh, they're not playing the same. They had the little, what was it? The little top or kind of like a dreidel thing going and saying just, yeah. It was very quirky the way it was, but Einstein's famous mass energy equivalence equation, or E equals mc squared, is actually a special case, a slightly longer formula known as the energy momentum relation, which is written out as E squared equals small p squared, small c squared plus m2 m squared plus c4. Oh, that's very interesting. Well, m and c, that would be yeah. No, that would be like mc squared. That would reduce down to that, right? But you got this too. Is that why we're able to like convert like apparently now like actual like energy to like mass? A wee bit, according to Professor Keating, I heard. But I just found that interesting. It's a pretty photo. We go to our friend Wolfram Alpha. That's a photon. Assuming photon is a particle. Look, we got a little like I believe, is that a lambda? Oh god, I need to learn my Greek. Zero. Oh, the mass. Oh, it doesn't have a mass because if we're using that, we're assuming certain things. So yeah, we got our speed there, about 300,000 kilometers per second. Gauge, both spin barity 1, electric charge 0, isospin 0, 1, strangeness 0, hypercharge 0, mean lifetime infinity, half-life infinity with 0 megaelectron volts. Oh, that's interesting. Antiparticle is also a photon. You get a photon plus, what was that? 2 hadrons or something? Particle. Oh, a deuteron. It's a deuteron. Oh, it's also a musical note. Cool. But, oh, physical quantity. Oh, no. Particle. That's what we want. Oh. That's like 2 proton masses. I think that's like helium. No. That's interesting. Oh, it's hadron 2, basically. Okay. It's okay. It's okay. We're making some assumptions there. It's technically a deuteron. At least according to that. Okay, so photon plus photon leads to hadrons. And a photon plus, what is that, proton? Yeah, proton. That's a lot of mega electron volts. Apparently the top quark has more. But, yeah, it can lead to anything. Now, I'm just saying people have traveled really far for salt. I don't know. I'm just saying that it seems to be emitted from a lot of these experiments. And it has the ability to, I don't know, have more energy in it. Is that the whole like gamma rays and everything? Oh my god, look at the energies here. It's like, yeah, what's actually gamma ray? We go back over here. Boop, boop, and boop. There we go. Let's take a look. Because we can. Okay, they're just going, da, da, da. Well, frequency is equal to energy, right? Oh, 3 times 10 times 3 to the 11 gigahertz. Oh. Okay. Energy. All right. How about can't spell. Oh my god. Radio wave. We're just doing normal photon. Is Wolfram Alpha tricking me, or am I tricking myself? Probably. We set it as a oh, is a unit. Wow. Oh, it is a unit. Okay. Give me negative 18 micro Einsteins. Okay. All right. I won't waste anyone else's time with that. The other stuff I actually looked at, but all I'm saying is it seems to be expended when we heat a lot of stuff up. I don't know. Is that like heat and stuff? Is it actually photons? I'm just saying things we should consider. Maybe other relationships between different things. Maybe a different perspective. Maybe include some additional disciplines and just maybe, I don't know, communicate with your fellow human being and maybe we can learn something. At least that's what Professor Peterson taught me at one point. Assume I can learn something. I try to learn. I don't always succeed, but thank you all for watching. Peace out, everybody. Be safe and take care of yourselves. Happy New Year, everybody.
Have you guys checked out the Memes of Destruction's channel? He's an interesting dude. I like him.